Let's consider a point on the unit circle. Any point on the unit circle can be related to an angle whose terminal side passes through that point. And as we've done with angles in standard position, we can draw a reference triangle and consider the coordinates of the point. We can consider the x, y coordinates of the point and use them to describe side lengths on the reference triangle, where y is the vertical distance, x is the horizontal distance. Those could be positive or negative depending on the quadrant. And r is the length of the hypotenuse, given by the formula square root of x squared plus y squared. Of course, for the unit circle, the value for r is going to be 1. So if we think about the trigonometric functions, like sine of theta, as before it's defined as y over r, but in the context of the unit circle, r is equal to 1, so we have y over 1, which is the same as simply y. Likewise with cosine, cosine is defined to be x over r, but since r is 1 for the unit circle, the value of cosine theta corresponds to simply x. So the unit circle is special in part because we can think of the coordinates as equivalent to the sine ratio for y and the cosine ratio for x. Another way to think of it, the other perspective would be we can think of cosine as keeping track of the x coordinate. It starts out at 1, and then as we go around the circle it goes to -1 and back around to +1. And for sine, it starts at 0, it keeps track of the y coordinate, it goes up to 1, and then down through 0 to -1, and back to 0. And so understanding coordinates for points on the unit circle can be useful. And so what we end up doing, we identify some special points relative to, say, a 30-degree reference angle. There are 4 points on the unit circle that correspond to a 30-degree reference angle. There are 4 points on the unit circle that correspond to a 45-degree reference angle. And there are 4 points on the unit circle that correspond to a 60-degree reference angle. In addition to those, if we add in the points where the axes cross the unit circle, we end up with 16 special points on the unit circle that have very nice coordinates, because the reference angles related to those points have exact trigonometric ratios. In particular for sine and cosine, but for the others as well. So maybe I should add, we can define the other ratios in a similar way. Tangent of theta is still going to be y over x. Cotangent is still going to be x over y. Secant, we can think of on the unit circle, secant will become 1 over x. And cosecant will become 1 over y. So let's take a look at the special points on the unit circle and try to identify the coordinates of those points. To think about the special points on the unit circle, let's focus on the points in the first quadrant. We're interested in understanding the coordinates that relate to a 45-degree angle, a 30-degree angle, and a 60-degree angle. And so to think about the coordinates related to those, we can think about the special right triangles. We've seen and worked with 2 special right triangles, a 30, 60, 90, and a 45, 45, 90 right triangle. The side lengths that we attached to those, for the 30, 60, 90, we used 2 and 1 and the square root of 3. If I want to think of that in relation to the unit circle, however, the hypotenuse, I want to change that from a side length 2 to simply a side length 1. And then the 1 has to become a 1/2, and the square root of 3 becomes the square root of 3 over 2. In a similar way, with the 45, 45, 90, earlier we talked about that as having side lengths 1, 1, and the square root of 2. But if I want the hypotenuse to be equal to 1, to kind of fit onto the unit circle, I can think of dividing everything by the square root of 2. So then the two shorter sides become the 1 over the square root of 2 and 1 over the square root of 2, or the square root of 2 over 2. So on the unit circle, in the first quadrant of the unit circle, I can think of coordinates at these three different points. I can think of coordinates by thinking of the 30, 60, 90 right triangle. And to make a slightly better picture here, the 30-degree angle is going to be here. And so opposite the 30-degree angle is a side of length 1/2. The radius, of course, is 1. And the x coordinate, the x side, is going to be the square root of 3 over 2. So the coordinates of this point are the square root of 3 over 2 is the x coordinate, and 1/2 is the y coordinate. But I think it's most helpful to kind of think of that position in relation to the special right triangle, the 30, 60, 90 right triangle that can fit into that space. For the 45, 45, 90, in a similar way, I can think of the special right triangle that relates to that. And so in that context, we have a 45-degree angle up here, 45-degree angle down there, and so the coordinates of this point are going to correspond to the side lengths of the 45, 45, 90. And if the hypotenuse has a length of 1, then the x coordinate and the y coordinate, we can think of both of those as the square root of 2 over 2. Finally, the 60-degree angle, if I think of the hypotenuse here as having a length of 1, the 60-degree angle, the point associated with that, is going to relate to a right triangle where the shorter side over here has a length of 1/2, and the y coordinate has a length of the square root of 3 over 2. And so the coordinates are going to be x equal to 1/2 and y equal to the square root of 3 over 2. We can sort of complete our picture of the first quadrant by thinking of the point on the y-axis. The coordinates there are 0 and 1. The point on the x-axis has coordinates 1 and 0. And then to think of the unit circle as a whole, looking at the entire unit circle, right, rather than just the first quadrant, we can extend to the other three quadrants by thinking about the symmetries. So the 3 points that we've seen in the first quadrant have symmetric partners in the second quadrant. And I can get from one to the other by thinking of reflections across the y-axis. That's going to keep the coordinates the same numbers but change the signs. Some of the signs, the x coordinates, are going to change from positive to negative to get from the first quadrant to the second quadrant. In a similar way, I can think of the symmetric partners of these points, of the points in the first quadrant, down here in the fourth quadrant. And to get from one to the other, I want to think of the symmetry across the x-axis. And so the positive points that exist in the first quadrant, when I move them to quadrant 4, when we think of their symmetric partners, those points are going to have y coordinates that are negative. The x coordinates are going to stay the same, and the y coordinates are going to become negative. And finally, we can think of points in the third quadrant as reflections, symmetric points across the origin. So the positive values in the first quadrant are going to turn, both x and y are going to turn to negative values, but the numbers that we saw are going to be the same. So from what you've seen in the video, consider the following question. What I'd like you to think about, take a few minutes and try to sketch out a diagram of the unit circle with the coordinates for all 16 of the special points that we just talked about. So I guess it's not really a question, but an activity. I hope you enjoyed the video. Thanks for watching.